worked on the implementation of Lift Cover Plus, which is an upgraded version of a pre-existing ILP system that performs both parameter and structured learning. With structured learning, we learn a set of logic rules, so logic theory, and with parameter learning, we set the probabilities of the rules. I have applied Lift Cover Plus in different contexts. For example, for a knowledge graph completion. A knowledge graph is a graph-based structure that represents the knowledge of a specific domain. And sometimes this graph can be incomplete. So if we can use Lift Cover Plus to predict missing pieces, for example, connections and nodes. Another scenario in which I applied Lift Cover Plus is the industry scenario, in which we have integrated Lift Cover Plus in the pipeline of a debt collecting company. And also in the medical scenario, I've used the Lift Cover Plus to perform a diagnosis prediction. I've also worked on another logic framework, which is probabilistic answer set programming, in which we performed parameter learning for probabilistic answer set programs. Finally, I have also worked on the integration of logic and large language models, like, for example, ChatGPT, to enhance the explainability of logic theories. And I did this work during my 6 months period abroad, which I did here in Japan at the National Institute of Informatics in Tokyo. So this concludes my presentation. Thank you very much for your attention.
Very, very good and sharp. So, who's next? Okay, great.
Good afternoon, everyone. I'm Elisabetta Savino, and I'm an industrial PhD student at the department DICAM at the University of Bologna, and with the company Caracol. Me and my research group are structural engineer, and we are working on metal 3D printing in construction. The technology that we use is called WAM, Wire Arc Additive Manufacturing, based on a MIG welder machine moved by a robotic arm. These technologies give the possibility to print in two different ways, in continuous, layer by layer, and dot by dot. The technology is particularly suitable for make large-scale dimension because it is possible to print a monolithic construction, as the small column prototype that I have here. And we not only studied the structural behavior, but also other aspects. For example, we discovered that by making topology optimization, we can reduce the CO2 environmental impact about 17%. The study case was a node in the grid shell of the British Museum of London, and we make a strong topology optimization that is intrinsic to the 3D printing. And we reduce the weight more than a half by resulting in a decreasing of the environmental impact. Also, since we believe in this technology, we make a survey to know if the world is ready or not to use WAM. And we did this survey for students from the major university in Italy, students in construction fields, and also in engineering construction company around the land of Italy. And we discovered that students are more prone to use WAM. In general, we discovered this. But also you can join our survey with the QR code if you are students or professionals. And then currently, during my PhD with the company Caracol, I'm working on the connection of plastic lightweight cover shell connected to a steel structure. So we are making a mechanical interlocking combining 3D printed polymeric and metal. We are really believing this is a challenge because plastic and metal really different as a behavior and manufacturing. But we need to change a bit the material construction that nowadays we are using. Thank you very much.
Super good. So, yeah, let's move on.
Yes. Okay, can I go? Thank you. Good afternoon, everyone. I am Giulia Scaramuzzo, a PhD candidate in environmental, food and agricultural science and technologies at the University of Bologna. Specifically, I am from the curriculum of international cooperation and sustainable development policies. So my research focuses on co-designing and testing behavioral interventions to promote healthy and sustainable eating practice in collective catering. So together with my research group, we do apply this methodology to different projects. One of them is this Laboratorio di Ristorazione Sostenibile, which is a project we conduct with the Regione Emilia-Romagna, and it is also called LARISO. Which are the key objectives of this research? So first of all, the education towards sustainable and healthy diets. Actually, collective catering is not just about food, but it's about education, sustainable and healthy eating. So when we do educate our children, we are educating our future society. Secondly, another objective is the engagement of stakeholders in order to do these interventions. Since a collaborative approach is something that is needed in this very complex food environment. And finally, the other objective is the evaluation of best practice to that could be useful for policy proposal, present or future. Okay, so how is this done? About the methodology, usually there is a problem identification, which in this case is food waste in school canteens, and then a living lab is always been set. What is a living lab? Is a group of stakeholders that all together collaborate to design interventions. In this case, for food waste, we're talking about teachers, food service, nutritional or regional institution, and researchers as we are from University of Bologna. And then all together, these people co-design behavioral interventions. And this is the first phase. The second part of this methodology is about testing the intervention that we do implement. So how do we do it? We do it in presence, and we implement these interventions, first of all, and secondly, we do data analysis, we do data collection. After the data collection, we do data analysis. Once we have collected and analyzed the data, we try to understand which are the best interventions that we have made, and we do some policy proposal. So to close, the aim of this methodology is to connect research, schools, institutions together with the participatory approach to promote healthier and more sustainable eating habits, starting for now from collective catering. And that's how my presentation ends. Thank you.
Thank you very much. Okay, we move on.
So, good afternoon, everyone. My name is Leonardo Gasperini, and I'm a postdoc researcher at the University of Bologna under the Limes laboratory. And today I would like to introduce you about my research topic, and particularly on developing new materials for storing and producing energy in a smarter way. We all know about the importance of batteries, and how batteries are important, of course, in our daily lives, starting, for instance, from laptops and phones, but also nowadays are important also for vehicles, electric vehicles, of course. And but batteries need to be safe and long-lasting. That's why part of my research is on developing on a very thin part of the batteries, which is called the separator. The separator have a crucial and key role inside the batteries, and by studying this, we can increase the final performance of them. So the key technology of my research is the electrospinning technique, in which we are able to spin very, very fine threads, very fine fibers, with a diameter that is almost 10,000 lower than a human hair. And with this, we are able to fabricate, to manufacture membranes which can enhance the performance, the final performance of the batteries. But my research is not focused only on storing energy, but also on harvesting it. So in other words, on generating electricity from the world around us. So for instance, and more specifically, my research is focused on piezoelectric polymers, which are able to convert vibrations into electricity. And particularly we can think about vibration from machines, or also vibration from walking, breathing, or running of a human body. And so we are able to convert this vibration into electricity to charge, for instance, small electronic devices, to power more electronic devices without the need of constantly recharge them. So in conclusion, to sum up, my research is focused on developing new materials for energy storage systems, such as batteries, separator for batteries, or supercapacitor, and also on a new way to produce electricity from the world around us. And I think that could be a possible solution towards a greener and more sustainable energy solutions. So that's all for me, and thank you for the attention.
Can you hear me? Great. Thank you very much. Good afternoon, everyone. I'm Marcello Brugnoli, Research Fellow at the University of Modena and Reggio Emilia. Now, let's image. What would be if we can turn or transform wastes from food industry into high-value products? And I'm talking about functional beverages, advanced biopolymers, and so on. It would be amazing, right? Well, there are several keys, actually, to unlock this vision. And one of these keys is acetic acid bacteria. My research, starting from the Unimore microbial culture collection. The UMCC is a library where different bacteria and yeast strains are preserved. And every single strain has its own characteristic. Some tolerate high acidity, some high ethanol content, some metabolize sugars into organic acids, and others spin out fibers of bacterial cellulose. So by choosing the right bacterial strain means designing the right product. When we cultivate acetic acid bacteria, the outcomes are remarkable. Indeed, we can obtain fermented beverages and organic acids. Besides acetic acid for vinegar, we can also obtain gluconic acid, which is extremely valuable in clean label formulation. And on the other side, we have bacterial cellulose, a pure, flexible, biocompatible nanostructure material, which can be tailored in shape and properties. Bacterial cellulose is already being used in biomedical fields, from wound dressing to tissue engineering, proving what is its adaptability and scalability. So again, by choosing the right strains, we can move from food application to material science. This brings us to industrial potential. UMCC collaborate with several corporates like Ponti or startups like the Italian Noyet or BioVega and so on. So in conclusion, acetic acid bacteria can bring us to a more power and sustainable products, both traditional and cutting edge. Thank you very much.
Super good. Thank you, and very, very good talks. So opening the floor, let's do like this. I wrote down, from my point of view, some keywords. There were AI, industry, optimization, CO2, policy, energy, critical materials, products. Just okay. Following the same order, I'd like you to comment on this, either finding a connection to what a colleague of yours said, because in your life you have to create projects, okay, intermultidisciplinary projects, so you have to find connections. So you were inspired maybe by some links connection, or if using the information I'm sharing with you, maybe you know or not, the price of CO2 in the European market is 75 euros per ton. Is this so? Either finding a connection or using the information for your project that CO2 has a price.
Thank you for your question. I think that AI nowadays can be really applied to anything. So finding a connection can be quite easy, but actually applying AI, maybe it's not so easy because of regulations and policies, both internal, industrial, and also laws. But regarding the projects of my colleagues, I think that maybe in your project, I think I saw like healthcare observation. Maybe AI can be integrated to, I don't know, maybe put together more data about someone, and maybe give alerts based on what you collect, and also other data about the patient. But also your project about materials. Maybe AI can be used to, I don't know, analyze some images to find maybe failures and predict failures and something like that. So maybe I'll give the words to.
Thank you. Okay, about the CO2, I think is the great potential of the 3D printing, but in my case, metal 3D printing, because as I said, with the topology optimization, we can cut the weight, no? Because topology optimization is to deposit material only where is needed, no? And more than a half of a normal structure, steel structure, we can say, is not used. The path of the load is not really used. So we can make optimization to just produce what we need, no? And this is about the CO2, no? So we decrease a lot. And yeah, that's true. We really need a control system for our system, because we are improving this technology, but nowadays we cannot leave the machine to make a welder alone. So with AI, it's fundamental to make a control and to have an alarm if something happens. But I want just to say, in general, I'm impressed on the fact that everyone spoke about sustainability, CO2. So I'm glad that there is new vision around young people.
Just adding that, when, for example, you said that you have a minus 70% CO2. Okay, so the current price is 75 euro, but could also include the expected price that we don't know, but could be expected. Estimation are 250, even 350 in 10, 15, 20 years. So there is also a saving in terms of expected saving. Okay. Okay.
Okay, so about connection, I think that, yeah, I found a connection with your project. Food waste in industry can be somehow also seen in food waste, like at a smaller scale. We should discuss about it maybe, but I think it's an idea. And for what concerns the CO2 and the price of CO2, it comes into my mind the project that actually we presented yesterday with the public engagement Labo 2030. We had this school with this class of the Liceo Ettore Majorana. Yes, it's a high school in San Lazzaro, nearby Bologna. Actually, they worked on these school canteens they would really like to have, and when you talked about CO2, it came into my mind that they proposed a lot of vegetable alternatives, and when we worked with them, we saw it for the first time. It was very impressive. I know that it's something that we talk a lot about, but they really focused on, yes, on vegetables, like meat alternatives and things like that. So, okay.
Great. So now it's your turn, please.
Yes, thank you for the interesting question. Yes, well, regarding CO2, I think that we all know how important are electric vehicles nowadays, and I think that we have to change our focus on how we produce electricity. I mean, in Italy, we still produce electricity from oil and from gas, so from fossil fuels. So if we want to change and change all the mobility, all the transportation, and use only electric vehicles, we still need to implement and study also new ways of producing electricity. That's why I think it's important maybe using also, as I study, piezoelectric polymers or other new materials that can help us storing and producing energy in a more greener way. So regarding this, I think that's all for me.
Thank you. And final speech?
Okay, regarding the CO2, I would not talk about the price, but whether I would do a focus on the dependency on a specific molecule or material. For example, for us in microbiology or biotechnology lab, we had a huge constraint in CO2 availability back in 2021, 2020. So I think it's more related, besides the cost, which is, of course, driving the dependency or the demand, I think we should also find some ways to unlock different materials or find different ways to reach the goal that we are expecting.
I don't know. We had a 7 minutes discussion. I don't know about the time constraints. Should we go on asking the organizers or from the floor? Are there questions? Super curiosities? From a point of view, we could also stop here. I don't know. Perfect.
How do you see the implementation of explainability of neural networks, for example, in a field like 3D printing infrastructures, where if you even dream of having a building code that allows 3D printing in construction and you use AI for optimization and generative design, how exact is the explainability, or how much can you explain what's happening, and is it going to reach a level that can be ruled in a construction tool, for example?
Yeah, so thank you for the question. Neural networks are not exactly my focus, but I know there are a lot of explainability techniques also for neural networks. For example, you could use heat maps to highlight which pixels were considered more by the networks, which pixels were used to make the prediction, and maybe how much they were considered important for the network to make that prediction. And so this is maybe the most explainable technique because it's easy to understand. You could just have a look at the heat map and you could understand immediately where the important parts are for the network. There was a really interesting images backwards when I was a student that was used to explain neural networks. And there was this image of a horse, and the neural networks were used to predict whether the image was a horse or something else. And all the networks predicted 100% horse, but because they focused on the label of the factory where they were. And so, yeah, it could also be misleading. You should pay attention to what neural network, to which pixels neural networks use to make the prediction. So maybe, yeah, heat maps are the best choice for this.
Okay, maybe time if you have very short, please. Okay, maybe we can, she already replied, so we can use the other 4. Very quick.
Thank you for your question. It's it's really a relevant topic. I mean, the communication between the different fields or people with different knowledge, basically, it's crucial. Personally, I try to set the conversation at the very beginning, at the, say, not low level, but I avoid technical technicisms like species name or so on, because they are kind of confusing, even for microbiologists, actually. So the importance is to be passionate about what you're doing and try to have some sort of empathy with who you are talking to, in order that that person can really understand what you are doing and feel that you are passionate and you are on a sort of mission, basically.
Thank you for your question. I think it depends. You asked for researchers, right? Like communication between with other researchers. In general, okay. Okay, so for the general public, I think like what he said is very similar to the way I act. While if I communicate with people that somehow have other kind of expertise in different field, I try first to understand which part of my team can be like influenced by what these people study somehow. So this is usually when I talk with other researchers, for example. I try first to understand what they do. Yeah, and then I also try to communicate the urgency of what I do, especially like sustainability matters, but more like, yes, specifically also on what they do. I don't know if I explain it well. I was trying to at least, okay.
Yeah, not really to add what my colleagues already said, but for me, it's really hard every time that I need to explain my topics to the other people. Is super hard for me because I need to make a really large introduction about the construction, what type of construction we have, steel, concrete, wood, and why we need to implement the construction field with metal 3D printing. And every time I need to explain that we really believe in this, but people want numbers. Are they strong enough as a steel structure? So every time I need to explain everything in a detailed way, but yeah, and it's a bit hard, but with the time also you can improve yourself to explain, to make a summary of your research. Thank you.
Thank you again. So we can conclude.
I mean, regarding my experience, I think that in general, explaining the biggest theme, biggest part of my research is easy because everyone knows about what I already listened about that something. But then if I have to go more deeper, of course, it depends on the audience and generally it could be very hard to let them understand all the part of what I've done and what are my projects about.
Okay, I guess we're done here. So always a pleasure to stay within PhD students. So thank you. Okay. So next slot. Guys. 4 of you, yeah, we've Okay. Yeah.
Can I go? Good afternoon, everybody. I'm Matteo Lanza from the University of Modena, Reggio Emilia. I am a PhD student in physics and nanoscience, and I work at the low temperature lab in Modena. I would first like to thank the region for having me here at Expo to share my experience, my PhD experience, and for having me here at Osaka, since I was able to meet Professor Katsunobu Sato, which is a professor in chemistry of the university, the Osaka Metropolitan University. We have an active collaboration with them, and I was able to visit their laboratories and share with them my experience. So my work focuses on quantum technologies, which is a topic which is really interesting when you look inside of it, because we need to go out and look, first of all, at normal technology. Right now, you are recording videos, you are looking at your smartphone, and the basic element of this is the bit. The classical bit is an element that can be either 0 or 1. And the physical element that corresponds to this bit is a transistor. This is like the small Lego brick that builds up all of our technology. Now, if we want to look at the quantistic counterpart of this element, we have to look at the qubit, or quantum bit. The qubit is an element that could be 0, 1, or a combination and 0, 1 at the same time. This is a really strange concept and have a lot of physical counterparts. So the one we focus on in Modena is our molecular spins. These molecules can actually act as qubits, and to have them, we work with chemistry laboratories in Modena and in Florence. They provide us these crystals that you can see here under the molecular spins part of the slide. And it's this small yellow crystal that you see at the center of this coil. So why should we use quantum computers instead of normal computers? The answer is because they can outperform classical computers in a lot of tasks, not in everything, but in specific tasks like encryption breaking and in quantum simulation. These machines have already proved themselves to be reliable and able to solve problems that are not solvable with classical computer, even in the lifetime of the universe. So they're really interesting. And another question would be, well, if they are this good, why are there not quantum computers everywhere? And the answer is that they are a nightmare to produce and they're a nightmare to control. To have a quantum computer, you need usually, for most systems, low temperatures, and we're talking about temperatures around 2 kelvins. For everybody which is not in the physics sector, 2 kelvins are minus 271 degrees Celsius, so it's quite freezing. And also, to control them, you need to use different methods depending on the system. In our case, we use microwaves. This needs complex wiring, as you can see down there, and also this can be achieved by using this black box that you see over there. This is called an arbitrary waveform generator. It's quite a technical machine. It's quite a marvel of technology, and for us, this is something that we bought from a high-tech company in Ferrara. And this is good because this shows us that the Emilia-Romagna region is, again, an excellence when it comes to producing good, high-quality technology. Now, if you like my research and you like what I do or you're interested in any way, I have printed in a small format my slide that Marcello here in the public can distribute to you all around. And that's it. Thank you for your attention.
Good afternoon, everybody. My name is Simone Morabito. I'm a PhD student from Università Cattolica, and the topic of my PhD project is population genomics and biodiversity analysis in South America cattle populations. In order to bring on my PhD project, we have worked with several universities from South America in order to collect data obtained from DNA of several populations of cattle that you can see in the slide. There are around 1,000 samples, and the DNA has been extracted to tissue and blood samples. We obtained what is called whole genome sequencing data, WGS data to be short. So this data allows us a base-for-base analysis of the DNA strands of the animals. This allows us to study the differences between nucleotides in the same position for each animals, allowing us to identify small but significant differences between each, not just animal, but each populations. WGS are really heavy data. We have data set that is really difficult to study. So the first step has been to carry on a cleaning of the data to obtain a smaller data set that is easier to study. This can allow us to identify which are the genomic distances between populations. As you can see from the image, populations that are similar tend to form clusters, while populations that are different are shown far from said clusters. This also allows us to identify admixtures events that are the meeting between animals from different populations that through breeding share part of their genomic data and can be then later studied and analyzed. This process allows us to have a glimpse on the historical spread of said populations, to understand how different populations came in contact and how they start from one point and are later spread in the rest of the country. Also, SNPs analysis, single nucleotide polymorphisms, allows us to understand which traits could be shared with other populations. It's really crucial because we can understand populations that have traits useful such as heat tolerance or a better milk production. And by seeing which population carry the better traits, we can program and identify projects, breeding projects for carry on traits that could be useful in the future. For example, we will for sure see an increase in population, but also an increase in temperature. These two traits will be crucial in order to have more preparation for the future. So to finish, the aim of my project is to define the genomic differences between these populations. But as secondary aims, there is also the possibility to reconstruct the history of the cattle migration and maybe compare them with the history of other populations from other regions for other places of the world, and also identify between all the population, all the breeds that we have, the population that are worth focusing on in order to prepare for the future. That's the end of my presentation, and I leave the floor to the next one.
So good afternoon, everybody. My name is Valeria Musso. I'm a PhD student from the University of Bologna. My PhD program is in agricultural, food, environmental science and technology, particularly on curriculum on sustainable food policies and international cooperation. So today I would like to talk about a topic that I'm focused on in my research, but also with my research group I'm part of, and I would talk, let's say, about food, but from a different perspective. So when we buy food at the supermarket, probably we think that we know the price that we pay is actually real. However, the number we see on the label tells us only one part of the story. Because behind every product, actually there are some hidden costs. And this cost actually comes from all those environmental impacts, such as greenhouse gas emissions, land and water use, but also social costs that are, for example, the costs that coming from unhealthy diets. All these actually make up what we actually call the true price of food. But actually, can we reveal this hidden cost in some way? We try to do that with our approach that unfolds in 3 steps. The first one actually is trying to quantify externalities using different methodologies, such as life cycle thinking approach, through a life cycle thinking approach, such as life cycle assessment. And in this way, we try to measure the impact of a product along its journey from farm to fork. Then, and secondly, we try to monetize these externalities. What we call externalities are, in economic terms, all those costs that are indirectly paid by someone else through, usually by the environment and society. And in this way, actually, we are translating impacts into economic terms. Only in this way we can understand, for example, how much a kilo of meat or an intensively produced apple actually truly cost. Finally, we move to the definition of corrected price mechanisms. But the key question is, why does it matter? Because actually, first, it allows to, of course, connect environmental and social cost with real-life economy. Because they are no longer abstract numbers, but they are now tangible cost. Second, it helps both producers, therefore farmers and who transform food as well, and consumers on the other side, to make more sustainable decisions, because now they are informed about the real value, the true value of their choices. And third, it provides evidence-based knowledge to design smarter and more forward-looking food policies. So here comes the challenge, who actually is going to bear those costs? This is the question. It would have been fair if the costs are on the shoulder of consumers, of course. So we need really to think, what is the role? And actually, we need to think that conscious and active policymakers and business need to take action to start to consider this approach, which is actually called true cost accounting. Because actually, this is not only about economics. It's about, of course, reimagining how a food future which is more sustainable, fair, and transparent, and gives back, let's say, the true also value of food. So thank you very much for your attention.
Okay, good afternoon, everyone. I'm Vittoria Tudisco. I'm a PhD student from Politecnico di Milano. My PhD is in management engineering, and in particular, I'm focusing on warehousing 5.0. So, what's warehousing 5.0? On one side, we have warehouses. Warehouses are a crucial element of current supply chains, as in the last decades, innovation and digitalization changed a lot the retail market. And traditional stores are becoming multi-channel or online platforms, and orders are more and more small and personalized, and also more frequent. This changed a lot logistics, both in terms of transport and warehouses, where orders are prepared. On the other side, we have Industry 5.0, which is a paradigm that in the last years have been fostered by European Union that suggests us to move beyond efficiency and try to design technologies that are more human-centric, sustainable, and resilient. So warehouses can be a perfect field to combine these two aspects, because recently warehouses have experienced significant levels of automation to cope with increasing complexity, but at the same time human operators remain crucial to guarantee flexibility and the end work required. In the meantime, human operators, unfortunately, are experiencing poor working conditions, sometimes with repetitive movement hindering their physical and mental well-being, that consequently also impact on performance. So this research focuses on understanding how technology and human operators can coexist, cooperate, or collaborate in warehouse, We have tested several technologies. First of all, exoskeleton that support human at physical level, but also robotic arms that share tasks with human operators, and also machine learning for time forecasting and also task assignment. But the objective is not to test technologies, but to understand how the human is impacted by the system and how the humans impact the system. And to really catch these relationships, it's important to model the human as part of the system. Our results show that human well-being and economic performances can be closely linked. Sometimes improving well-being can also improve performance, but in other cases, trade-offs are clear. What is important is not to eliminate trade-off, but to really understand this trade-off in order so that decision can be made with awareness about this trade-off, and so to provide tools for decision makers that have to design and manage warehouse, and to support decisions that balance well-being and economic performance by providing full awareness about their synergies and trade-off. Thank you very much.
Thank you to all of you. Okay, so for the joint project you will develop in the future, up to you. The keywords are high-tech, biodiversity, externalities price, humans, robots, and machine learning. So that's for the future. You can work. But besides that, there is a funny thing I share with you. I'd like to comment on that. I was waiting for the final, but even the final presentation confirmed this fact. If I had to choose, or I mean, the most frequent keyword which is connected to my CV after 20 years of research is innovation, eco-innovation. In 9 presentations, even if there were innovations or inventions, neither innovation nor invention was present. Please correct me, but okay. Which is pretty funny because you were, to me, talking about innovations and inventions, but you never mentioned neither innovation nor invention. So the question is just taxonomy, or why? Because it's, if we had to work together, I mean, my keywords is innovation and invention, eco-innovation and green patents, for example. So because some innovations can be patented, which are inventions. Innovation is more the adoption of things. So I was just wondering about that because it's pretty funny that because eco-innovation is one of the major drivers of sustainability, technological, organizational, soft tech, any kind of. So first.
So thank you for the question. I think that the first point is that my work in particular focuses on fundamental research. So innovation, as you were saying, is more linked to the actual application of something usually. And I think that another point for me at least is that when we start to write research papers, we are actually encouraged to avoid using words like new or novel, unless we are actually perfectly certain that this is the case. So I think that this caution actually is being brought up also here in this presentation, where maybe innovative sounds like a too bold word to say out loud. I don't know for the others.
Okay, I agree with him, and in my opinion, the point is that a PhD project is usually just really the start of a project. It's a really huge scope that will probably bring to innovation. But currently, yeah, we don't really want to think too much in the future. We are focused on our project that will probably, surely, hopefully, bring innovations. But currently, it's like a huge bet talking about innovations. If that's the way we are going with, it's the best, honestly. But right now, at least for me, I'm more focused on the first step towards innovation.
Before moving on, again, in this game trying to think about a project with all of us together. Again, a key word in my field or discipline, maybe it's wrong, is innovation. So radical, I add, or incremental. So even incremental innovations are for us innovations. Even the adoption of a very small type of thing which is reducing CO2 by a small amount is innovation. Then we can debate about it. Maybe you are right about the fact, but really in our taxonomy, innovation is a key word. Okay, I mean social sciences, economics, political economy, could be sociology. I don't know, but that's funny because that's part of intermultidisciplinary because you also come across situations where even taxonomy is an issue to start with. So again, your point.
Thank you for the question. I would say that in our case, in my case, doing research more related to economics and policy of the that regards agricultural and food policies. So it's completely different. So I think that maybe we don't talk about patents or we don't talk about technological innovation, let's say, in these terms. But I think that we talk about innovation as well, because sometimes, for example, I mean, my background is not in political science, but I think that also in research, starting to look at, for example, food from a different perspectives and realizing that actually we should start to also talk about in economic terms, for example, and start to, for example, include some cost, for example, in the price of food, or starting to realize that actually our production and our consumption patterns has actually impacts on society, on environment, and actually that we are the one that pays that cost, actually, the society, the environment. I think it's a kind of innovation, and also the research that we do is trying to produce innovation in policy, for example. So if the sugar tax exists or the carbon tax exists, it's because probably some economist or some political scientists actually studied that might be an instrument to start, for example, to internalize those externalities, for example. So the impact that you can produce maybe through our research is maybe more on that side, and I will try just to say that probably innovation means many things. Thank you.
Okay, I maybe agree with them about the fact that PhD research is low level, it's very specific, and we cannot already talk about innovation. For sure, we hope we aim at that, but as I mentioned in my presentation, I talked about innovation of the last decades, so something that is already done. But what I'm doing in my PhD right now, I would not label right now as innovation. I mean, it's not a keyword that I would use, but what have been in the last decades, that is what motivates the research. It's for sure innovation as general term, and also digitalization, which again is a general term. And this maybe I'll apply even more to my research, because in my case, I do not study new technologies, but I study existing technologies and just their interaction with the environment, with human. So that is the part that I'm studying, not the innovation that already exists.
Okay, still, it's very useful to me because, again, I stress this point. To me, instead, I connect the PhD activity with radical innovation. so really, it's something that I'm learning. So food for thought, for example, and then opening the floor on this issue. To me, I mean, that stuff, I don't know what you think about, to me, this innovation. Maybe I'm a humble economist, social scientist, maybe it's not, but to me that is innovation. Maybe we can discuss whether it is radical, incremental, or whatever, but yeah, I mean, another word could be change. I mean, because innovation, again, in my brain, which is maybe not the rule, but is a change. It's a change from the status quo. So that's why you may have radical innovations like moving from the I don't know, even in sport, you had innovations in tennis, in ski. You can apply this type of reasoning where you have a huge step in terms of in technological terms, or not, which is not just technological, because you have, for example, you may have a very huge behavioral change. For example, it could be in that part. I'm talking about lab cultivated meat. To me, lab meat is innovation. Then maybe radical. Okay, I mean, to some extent radical or not, because it is a spin-off of other things. So, okay, open the floor if you want to say something about this thing, reflecting upon. Yeah. Yeah. It remains that if we have to work together, if you want my team and myself and your team, we have to use or not this type of perspective, because that's my perspective. So that's any insights from the floor? Please.
Okay, thank you for this interesting question. Well, I believe that to do good research is very important to understand very well what has been done. Sometimes I talk to researchers that are a bit annoyed by studying what has been done, but I appreciate that a lot actually, because I think it's very important. And starting from that, I try to sometimes build on that to improve the quality of the research. And another things that I find very useful is to move away from your field and try to understand methodologies or ideas from other fields. So try to combine methodology that exists in your field with methodologies of other fields to like make it stronger, to improve the quality, to go deeper or broaden a little bit the scope. So this is a way that I like to try sometimes.
Well, for me, I think that probably the way we can keep, maybe also in my field, in our field, a step forward is maybe not to and make an innovative approach to our research. In my case, I think it's more like get contaminated also from other disciplines, so not to think in silos, because usually collaboration among disciplines, for example, in our studies, gives a lot more value, I think, to our research, because usually our research doesn't affect only our field, but affect more. So I think that this is something that this approach can enlarge a bit your perspective, and I think research now is a lot, or has been until now probably a little bit more too much in silos. This is my perspective from what I let's say know. Of course, maybe I'm wrong, but I think that as our approach is and what I think that I like about also my kind of research is that, so contamination also, and thinking out of silos.
Okay.
Yeah, I agree with the contamination. It's crucial to not just have one point of view from your discipline, but to take in consideration and obtain knowledge from other points of fields. But my other idea is that research keeps moving. For each of our fields, every day, a new tool, a new idea, a new knowledge is thought by someone in another point of the world. It's a matter of being on the point, keep knowing what is next, what is new, what could be useful, and never be scared of try to apply that new knowledge to your research. Like you start your PhD, you start every project with your idea, with your method, but you can always try to get a different point of view, get a different tool, try something new, try something that is been thought by someone, and maybe the results will not be something that is worth being published, but by trying and by keeping your mind open, you can always get the right idea or the right foot towards something new and have a publication or a research that brings something new to the coming research. It's a cycle that keep going and keep helping the one that comes after you.
Yes. Thank you. I do agree that both contamination and trying different things you can find in literature is a really important thing in research. But I will also like to highlight that I think there is a lot of value in doing what you think. In the sense that as a PhD students, we are used to not feel like we are in control of anything, essentially. We can have ideas, of course, but of course the last word is from the tutor. So my tutor used to say, when I try to propose something, why this has not been done in literature? This is the first question, which is a really good question, actually. It's not dumb. But the point is that sometimes something has not been done in literature and can still be right. So I think that you should also trust your own instinct in these things. And if this thing can be done in a reasonable time, of course, you should try it. And if it requires like a really big amount of time, then you should just think about it like twice at least. Then you can try it again.
Okay.
Okay, to conclude on this point, another things came to my mind is that I totally agree with them that it's important to have ideas from other fields, from other methodologies, and also to apply our own ideas. And in conclusion, I think that it's very important for the quality also to validate. The validation is very important because even if he was saying, okay, this is not in the current literature, this has never been done, as long as we validate our idea, the work can be strong.
Okay, guys, so thank you very much. So let's innovate through dialogues and strong contaminations and communications. Okay, I think we can conclude here. So thank you very much.